PhD student working in robotics area, and today I want to talk more about my ongoing PhD project, which has been in robotics in agriculture. And I want to talk more about a special field learning with an autonomous robot. So let's first start with background and motivation. As you know, we can use robotics and robots in agriculture for specimen collection, crops monitoring and analysis, crops fertilizing, irrigation, weeding, and spraying. So the idea is sending a robot into the vineyard or orchard, and then the robot can take samples from the soil or cutting the leaf of the trees and then check the moisture of them or any organic material in the environment and soil. So here the challenges is that the robot operating in orchard, the constraint emerges because of limited energy. So the robot has like a battery and it cannot go further when it runs of energy. And also there are some kind of environmental features which affect the robot's performance, like irrigation lines, ditches, trails. So in that project, we made some contribution. We will talk about what is informative path planning in next page, but we allocate a resource for the robot, and also we consider the spatio-temporal variation of the environment, which means that we have like a Gaussian process, and we use Gaussian process to model the spatio-temporal variations of the environment, like moisture level of the environment, and we model it with Gaussian process. Also, we have considered and formulated the dynamic environment, which means that we have considered the stochasticity and noise in the environment. So maybe the robot tries to move forward, but maybe it turns left or right. So, as I promised, what is the informative path planning? Here in the right picture, you can see the vineyard and plan and with yellow pins, which shows the sample locations the robot tries to visit, and also the red star, which means the start location of the robot. And the robot, the idea is to plan a path for a robot to visit as many as sample locations while it's being considered the energy constraint. And if we want to briefly explain that how our method works, here we considered a set of sample location, the start location, the final location, the budget, and the idea here is that we have used like a queue learning method that the robot iteration by iteration can find out that how and what is going to be the best series of locations to visit. So in each iteration, we will check the robot consumed energy with the budget, and if it runs off the energy, we will assign a big penalty to it. And if it is less than the budget and visited the final location, we assign a big reward to the robot. So in that case, the robot iteration by iteration will find out that what is going to be the best locations to visit. So because of the time, I cannot explain the detail of our method, but I want to show that some simulation result that how our method works better than some baseline algorithm like greedy method and random method. So we've compared our method with in different environments, and the number of visited location, the energy they've consumed, and number of failures. Also, RMSE is the error between the predicted model and the underlying model, the ground truth. So here, for example, in model 1, you can see that the learning method, which is our algorithm, and the robot can visit 43 um, sample location out of 100 sample location, while greedy method visited 46 sample location. And in this case, maybe you can say that greedy algorithm works better, but if you look at the RMSE result, you can see that our method has a very less RMSE. And here you can see that how it works. For example, in that photo, in that picture, you can see the underlying model and also all the sample location, 100 sample location. And this is the locations that our robot finally find out that are better and critical to visit. And this is the model that has been reconstructed by our model, our algorithm, and this is uh, the one that has been constructed by greedy algorithm. And as you can see, even though our algorithm visited less number of locations, but it can predict the underlying model very better. So I want to say that here you can see the importance and effectiveness of our algorithm and method on the agriculture, and in future it will maybe result in human being life. Thank you.